Good afternoon. Welcome to our webinar today on debunking Wi-Fi myths so that you can have secure and high-performing Wi-Fi. We have a lot of good information here for you today that will hopefully allow you to make your existing Wi-Fi that much better, or if you're looking towards a replacement or an upgrade, to be able to plan that and make sure that you end up with the kind of performance and security that you're looking for. So I want to welcome you. I'm joined by Alex Wilson, who's a senior wireless consultant. So I'll do a few introductory remarks, and then Alex will be jumping in, looking at kind of the current state of Wi-Fi, and as well as looking at just general tips that you can help to try to make your Wi-Fi perform better for what you have. And then we'll kind of dive into different types of environments. We'll look at some of the kind of tactical gains that you can get. And in there, we're going to be really looking at a number of different myths, so probably about 10 plus a few bonus ones in there. And I think they'll be helpful to kind of um, elucidate and be able to help you work through the kinds of things we have there, including kind of a strategic upgrade as well, if that makes sense for you. Q&A will be at the end, so we'll save that up and I'll talk about that in just a moment. Hopefully, if you asked for a pizza, that pizza is before you. If not, just note Julie Dellinger's email address on the screen. Give them maybe 5 minutes or so to make sure they found your office or your home. If not, go ahead and email Julie and she will try to solve pizza conundrums. A little bit of other housekeeping things. So first is audio is in presentation mode, so you can hear myself and Alex in a moment, but sadly we can't hear you, but we do that so that any background noise, music on hold, barking dogs, any of those kinds of things that might be where particular participants are located don't come through to the whole group. But I'll be monitoring the chat and the questions tab throughout today's session. You can reach me on chat with any thoughts that you might have. Any questions that you might want for the Q&A, just drop them right into the questions tab. I'll read them out to Alex at the end and we'll be happy to take care of those for you. This presentation for the PowerPoint as well as for the recording of the presentation will be sent to you later today, so that you'll have that, along with an evaluation, which takes literally 1 to 2 to let us know how we did. We pay very close attention to that because we want to make sure these sessions are as valuable and educational for you as possible. So just a little bit for background for who System Source is, if you are kind of joining us for the first time, as well as for our many old friends of System Source here. So we've been around since 1981. And so we work with IT professionals in Southern Pennsylvania, all through Maryland down to the Washington, D.C. area. And a lot of folks come to us when they first need to acquire new technology. For today, that could be looking at Wi-Fi or switches or the types of things that would support that wireless network that you might have in place. Most of the work that we do today is in the modern data center. We do some end-user computing, but probably 80 or 90% of what we're doing is happening in the data center today, whether on-prem or in the cloud variants, whether that's Microsoft Azure, Amazon Web Services, co-location facilities, SaaS, wherever you can kind of stick your servers and your data, those are the kinds of places that we work. So our work is in a very heavily hybrid sort of environment. So we're going to be looking at, what kind of server or compute resources do you need, storage, security, networking, firewalls, virtualization, all of those types of things happen by our consultants in looking at really modern data center types of work. So people really are acquiring things. So we touched a little bit on what our consultants do in our cloud services. We also have a large training arm, training on about 600 to 800 or more students in any given month, and about 600 different courses, which are available. So those are available all online, as well as in our facilities if you wish. And those are going to probably about 3 dozen different either manufacturer specific, for example, say Cisco training, or general training like security training, or of the Microsoft stack. All of those types of things are available, and you can see the details right on our website. Our present is professional AV, digital signage, WebEx rooms, Teams rooms, all those large monitors, speaker systems, microphone systems, all of the types of things that our professional AV group does. And finally, we maintain all these things either on a reactive basis under support and service. You call us when things go bump, whether that's during the day or at night after hours, whether you have a contract or not. You just follow the voice prompts on our main number after hours, and it'll get you right where you need to be. As well as on a proactive basis, managed services, where we are the IT department for dozens of organizations. So that's a little bit about System Source today. I think we do have a couple of other webinars coming up, and then we'll have a full slate for the fall here soon. So we'll be looking at AI next on the August the 5th, and that's going to be looking at kind of AI from a security standpoint. Is it a friend or is it a foe or is it both? We'll be looking at that so that you can dial in your systems better to take advantage of the good parts as well as to protect yourself from some of the faux parts. And then we'll be, for those that may be looking at a managed services relationship as a new one, or perhaps you are already in one, we're going to be looking at how do you kind of set expectations for a managed services provider relationship. So we have a lot of experience with that. We've seen lots of different variations of that. That's going to be a shortened version at 30 minutes, and that's coming up on the 6th. So that's what we have coming up, and I think I'll go ahead and hand this over, and we're going to debunk some myths. Alex?
Alrighty, good afternoon, everyone. Let's get into debunking myths. Couple of quick things. I've been around the tech world since the early DOS days, so I've got a little bit of a background in networking and wireless. Do a lot of work on the in-building, outdoor Wi-Fi, point-to-point, point-to-multipoint links, building out wireless internet service providers, and along with that, some fun every now and then, climbing towers, building them, getting into fiber leasing and things like that. So a lot of background in wireless and a lot of understanding. So we're going to start off with a current state just to make sure we level set everything about Wi-Fi today and what's coming and what's not coming and all that good stuff. Because also there are a lot of myths that flow in there as well. So where are we today? So today, Wi-Fi 7 is the current standard. However, Wi-Fi 6, 5, and 4 are also still considered relevant and available and current. You might start to hear a lot about Wi-Fi 8 now because, of course, marketing companies want to make sure that it's hot on your mind and you're itching to buy Wi-Fi 8 devices when they don't even exist and probably won't really exist for another 2 to 3 years. Right now, the current standard for Wi-Fi 8 is not due out until mid to late 2028. It is not relevant today whatsoever. It's something worth thinking about as a corporation, but as a small business or even as a residential or a large estate type, it's not really something that you even want to consider. There are some pre-standard devices being previewed already, but really, who cares? They're not based on what the final standard is because we don't know what that is. The focus with Wi-Fi 8, though, is going to be ultra high reliability. Not increasing speed, not introducing any new types of frequencies or frequency bands that we can use. It is strictly focusing on that ultra high reliability. So taking what you have today, making it more reliable, making it more resilient to some of the issues that you run into. So for now, ignore the hype. Keep in mind a lot of the lower end brands are just trying to churn the market. They're trying to get some revenue streams going, which is pretty common. Your big names are not going to even be talking about it for a while yet. One thing to always keep in mind too, and we still run into this confusion many years after Wi-Fi 6 was released. A lot of people think Wi-Fi 6 means it has 6 gigahertz support. That's not actually the case. The Wi-Fi 6 standard did not actually include support for 6 gig. That came about in an extension of the standard approximately about a year later when they introduced the ability of 6 gig to be supported. Make sure you're reading the specifications on any device you're buying because you might buy a Wi-Fi 7 device that does not have 6 gigahertz radios in it. We'll talk a little bit about that. So not all Wi-Fi 7 devices have 6 gigahertz capability. Some of them are just too small to fit 3 sets of radios in them. Some are designed for different purposes. Wi-Fi 7 does not require 6 gigahertz. It just requires 2 frequency bands. It can be 2.4 and 5 it could be 5 and 6, it could be 2.4 and 5. It doesn't matter. As long as it has two bands, it can support what they call MLO, which is the multi-link operation, and therefore it would qualify to be a Wi-Fi 7 device. So make sure you're reading the specifications. There are a lot of APs out there that do not have 6 gigahertz support, but they do state that they are Wi-Fi 7 compatible or equals. So a little bit about 6 gigahertz. It's a fairly new spectrum available to the public. However, it is shared with licensed users. These licensed users are mostly in the cellular telecom industry, and they use 6 gigahertz for long backhaul links. It has an incredible ability with the appropriate radios to broadcast over great distances. And we're talking about distances measured 10, 15, 20, 40, even 50 miles. And so you can create links between towers, between mountains, et cetera, and move traffic. And that is a licensed radio. It's to protect their investment. And so you can use 6 gigahertz on these outdoor devices, but it does require what's called the AFC, the automatic frequency coordination. Similar to DFS, it consults a database, checks to see if there are any 6 gig links in your area. If there are, and they're on a particular frequency, then it won't let you use that frequency for your 6 gigahertz. It may bump you to something else. And so it's important that these access points have a clear view of the sky. So these are outdoor units. And if you bring an outdoor unit inside and put it under, say, a metal roof, for example, odds are it's not going to get a good GPS reading. And so it may not ever actually be able to use those 6 gigahertz frequencies. So it's important to understand how these access points actually work. Indoor APs, as designed, can use low power indoor mode. They have access to all channels. It's limited to 30 dBm. They work great. But if you're going to use outdoor APs indoors, like in warehouses or auditoriums or gymnasiums, then they can use standard power if they can make that connection to the AFC. If not, they'll have to use low power. So to summarize real quick, Wi-Fi 7, absolutely the current top standard, and it's what you should be designing for today if you're building a new network or doing a major upgrade. Wi-Fi 6, absolutely a viable option. If you have Wi-Fi 6 capability today and it's working for you, maybe now's not the time to be considering an upgrade, and rather maybe consider down the road when things stabilize a little bit more, prices come down a little bit more, supply gets a little bit better, and so forth. Or you start looking at maybe that Wi-Fi 8 for a couple of years down the road. Wi-Fi 5, absolutely still viable, but you should be looking to replace that because the spectrum is pretty damaged at this point. Devices aren't going to be, those devices that are Wi-Fi 5 only are probably end of life at this point. And so your support and your serviceability start to decline. So one thing to keep in mind too is that one-to-one replacements of your older APs to the newer will likely result in bad coverage, simply because, for example, 5 gigahertz is going to reach out further than 6 gigahertz in most cases. And it's also going to be affected differently by certain building materials. As a result, if you're doing a one-to-one replacement, you may find that you now have coverage gaps, or you may overcover some cases. So it's important to do a proper design along the way. So as I said before, don't forget, Wi-Fi 8, not ready for prime time yet, not expected until May of 2028. Don't worry about the vendors pushing the devices. They're just trying to jump the gun for a little bit of cash. And it will be focusing on ultra high reliability. One of the interesting aspects of this ultra high reliability is that it will start to allow multiple access points to coordinate, working together to tune their signals. That is a huge benefit towards reaching an auto tuning that actually works. So let's dig into some of the myths of Wi-Fi. One of the first myths I hear a lot of is more bars equals faster Wi-Fi. And while that may sound reasonable, signal strength and throughput really are not the same thing. congestion and interference are still going to kill speed. So you might hear the coverage is great, or you may see that the coverage is great. In other words, you do a coverage test, you walk around with your phone. Can you hear me now? You're looking at the bars, you've got 4 bars everywhere. But coverage does not equal good performance. If your heat maps are solid green, you have too much coverage. And I've actually been through this recently on a couple of designs where the previous design put in an AP in every room or an AP every 15, 20 feet or whatever, because it looked good. They thought a green map was good. And the problem was they had too much coverage, which led to roaming issues, self-interference, self-inflicted congestion. The heat map, the beauty of it is it lets us see these things. So here's an example of where all green is not really that good. In the scale here, the APs are 50 feet apart. It's a wide hallway. We have a single access point in the center. It's reading neg 54 all the way out at points A and B. Those are 2 other APs. So the fact that it's reading neg 54 past another AP is a bit of a problem. And when you see the coverage on the bottom, this is showing the coverage of all 3 together. That hallway is solid green. That means my device is never going to roam. So if I'm connected to that one in the middle and I walk down the hallway, I'm going to go past that next AP and I'm not going to switch over to it simply because my device is not going to see a need to. And that creates issues because now when I go around a corner, suddenly I'm really far away from where I was and I'm going to likely have a complete drop. So along with that, the interference that's caused by all these APs on the same channels or overlapping channels could also, interference could also come from neighboring Wi-Fi systems. Other things that can do it, point-to-point, point-to-multipoint radios on the same frequencies, your radar systems. Some of your audio and wireless microphone systems use 5 gigahertz. Microwave ovens, Bluetooth and Zigbee and cordless phones are in the 2.4 range. And then, of course, we also have occasionally you run into private 4G LTE cellular systems. All of this interference increases your noise, drives up your latency, and as a result, your throughput goes down. Along with this, we also end up with a lot of congestion. So congestion can happen with overlapping channels. So with all these APs, if we have too many in the building, we're going to end up reusing channels too often, and they're going to step on top of each other. This is also going to have issues when you have high demand use like streaming. Some of your older legacy devices might be dragging the network down, or you have physical interference that's causing retries. Physical interference being obstructions, walls, certain decorative items, or like a statue in the lobby or something like that. Anything like this that can get in the path of Wi-Fi. The result is you end up with a higher airtime usage for each device, and that's going to cause dropped packets or high retry rates. When that happens, your latency goes up, and then your throughput goes down, along with the potential dropped connections. So here's an example of co-channel contention. We see this quite often. So you have 2 adjacent APs using 2 different channels. That's the perfect solution. We've got one on, say, channel 1 and one on channel 6. And everything works fine because those 2 APs, even though they have overlapping coverage, they're on 2 different channels, so we don't have a contention issue. Now, here we have 2 APs now using the same channel. And what's happening, and what you have to understand and remember, is that you can only have one device talking to one AP on the same channel at a time. So if you have 2 devices out there trying to connect to 2 different APs that are on the same channel, but they're overlapping physically each other, they can actually see each other, they have to wait for one or the other to talk. And so what this is doing is it's increasing the airtime and the pause and the delay, and the more and more and more of this that happens, the delay gets bigger and bigger and bigger to the point where it finally falls apart. So some of the sources of co-channel contention, one can be self-inflicted. So you have too many APs on your network. They're on the same or overlapping channels. You don't have proper separation. Uh, Separation can be physical or just by distance, or it can be obstruction that you put between them, like a brick wall. Many different ways. Maybe neighboring networks on the same channels, and then also other devices on your network that are broadcasting their own SSIDs, such as printers, screen share devices, audio systems, some of your IoT stuff, and hotspots. Just went through a real big rash of this with one of our clients where everybody was coming into the office with their Verizon or T-Mobile hotspot in their backpack, and it was, half the time it was turned on. And so we've got all this stuff broadcasting, creating a mess in the environment. So you want to reduce the interference and congestion through proper channel planning, using reasonable channel widths. In other words, you don't need the widest channel with the fastest speed. You want the narrowest channel needed to support your needs so that you don't use more than you really need. That'll give you more channels to work with. Also, you want proper placement so that you avoid too many APs in the same area. The proper use of obstructions to reduce the interference and reuse. Know your neighborhood. Get to know the RF spectrum around you. One of our customers we're working with this week, actually, we noticed a big change in the environment around them and made a simple call to one of the companies next door. And yes, indeed, they just installed a brand new outdoor Wi-Fi network, and it was interfering with our network at that point. Not illegal to do as long as it's not done in any intentional or mean manner. You can also prioritize certain applications on the network to try to help out with some of the congestion. This is your quality of service. Or you can consider upgrades to better equipment if that's the problem. So with that, myth number 2, we just need more access points. Well, I think we talked a little bit about this, but more APs without a proper design is just going to make things worse. It'll increase your co-channel interference and your contention, and that will drive down your Wi-Fi network. So more APs is not always better. Too many can lead to that channel overlap that we talked about previously. And while more APs might fix certain things, the key is to make sure the placement is correct. Your roaming decisions may get botched up if you're not careful. So here's a great example using a hall-fi design. So we have 4 rooms without coverage in the middle because we have 2 APs at either end of the hallway that are covering the rooms opposite of those, but they're not reaching the rooms in the middle. And so the first thing you think of is throw another AP in there, and that solved the problem. Well, it sort of did. We got coverage into the rooms, but now the hall's too hot. And so this goes back to that first example where we saw 3 APs in the hallway. Maybe they were put that way in order to solve this problem of getting into these rooms, but by fixing the room, we've now created a problem in the hallway. And so you can see the coverage and how it overlaps those 2 APs in the hallway. So when I isolate to just that single AP in the middle, we're overloading the 2 on either end. So now the next question, can we go to a 1 per room? Now, obviously, this raises the cost. It has to be designed properly because one of the challenges we find in a lot of schools, for example, is the wall leading to the hallway may be concrete, but the walls between the rooms are just drywall. And so when you put an AP in the room, it may actually pass into the other rooms more extensively than it should. And we've got a little bit of that issue going on here that you can see in that little small map off to the side where it zooms in on a single AP. We are reaching into the other classrooms, and that could create roaming issues if we're not careful. And so managing the power becomes critical here and bringing the power down so that it doesn't extend beyond where we want to cover. So the conclusion on more APs, most times more is not going to make it better. If placed right and powered correctly, more may be the answer, but it's not always that cut and dry. You've got to know how your facility affects the coverage. The key takeaway here, you need a proper design in order to make sure you know where you're placing them. So myth number 3, we ran a speed test. Everything's fine. The speed test came back great. Or did it? One test, one device, one moment tells you almost nothing. It's just a moment in time. It's at that exact moment, this is how things looked. Keep in mind, too, that a speed test is measuring the internet, not your Wi-Fi. So it's measuring the time that it takes to get from my device all the way through my network, out the door, down the street, out through the interwebs, and off to the destination, wherever that might be, and then come back. Every time you run it, it's also causing more harm because you're increasing your the amount of data you're shoving through the network, and your results are going to be kind of the same. You may see some changes, and when you see changes, is the change because of something on your network, or did the traffic take a different path to get there once it went out to the internet? And that's something to consider because you may not always follow the same path. 3 people running the same test are going to go different paths potentially. So are the results really that valid? And again, like I said, it's a one-time point-in-time test. The results make no difference 5 seconds later. So it runs a download and an upload along with a latency check against a server somewhere out there on the internet. It's testing everything from point A all the way to point B and everything in between. So they're not isolating that you have a Wi-Fi problem. They're just saying there's a problem. We don't know where it is yet. And so to run a speed test and say the Wi-Fi is bad, there's no correlation there. There is better testing. For example, you can do an iPerf from the device in question to a server on the edge of the network. That's going to tell you what your network is doing. Then you can iPerf from the device in question to a remote server and compare the results. So you can see where your issues might be coming in. A local iPerf should result in a very low latency, low single digit measurements, probably sub 1 millisecond. But again, when you iPerf to something on the outside, all bets are off. We also hear another myth, we don't need a validation survey. We put everything up, we just replaced everything the same way, whatever it was. Keep in mind, a walkthrough with the phone is not truly a validation survey. All you're really testing at that point is, do you have coverage? Validation surveys are where most of the mystery problems are born and can be fixed or found. You may say, you may do a predictive design, but you must do a post-install if that makes any sense. So in other words, if you're just going to fake it and throw the APs up and see how it works, do the validation at the end to see how it actually works, rather than waiting weeks upon weeks of complaints to see how it turns out. So a validation is not done with a cell phone or laptop looking at signal strength. It's not somebody walking around with a phone on a video call waiting to see if anything pixelates, because again, that's a point-in-time test. Professional grade tools such as Ekahau with a Sidekick or Hamina with a Nomad or Clip device, that's a proper validation. You're checking the signal strength, you're checking co-channel contention, SNRs, channel interference, interferers, other sources of noise. You'll get an easy to use heat map out of it, and you get comprehensive data that can be broken down AP by AP. So you can actually isolate a single access point and see where it's covering, where it's having issues. And so you can place, and then depending on the tool, there's also the ability to model at that point based on the data it gathered, what if scenarios. And we do this with Hamina. It's fantastic. I can run through a building using Hamina. We get all of our results recorded, and then I can sit there and play what if. What if I increase the power on this one, decrease the power, move it over here, change it out for a different model? And we will see the results as we do this, which is absolutely fantastic for troubleshooting. So why should you do a validation? It's going to confirm that the APs are mounted in the best location. It's going to use the data showing the coverage to set the power, to allow you to set the power correctly, to create proper coverage cells with minimal overlap. You can find your channel interference issues and adjust them. And then you can sort out the environment really in a few short days, if not less, versus trial and error methods that could take weeks or months and create a lot of lost productivity and frustration. Your users are going to get tired of reporting problems to you over and over again. This allows you to just shortcut it and get it right to the end and get everybody back in a normal mode of working. Myth number 5, we upgraded to the latest generation of Wi-Fi, so we're good to go. Maybe, but keep in mind a new standard isn't going to fix a bad design. And we've seen this over and over. Wi-Fi 5 done right will beat out a Wi-Fi 7 done wrong. When you rip and replace your access points without engineering the design properly, it is just a recipe for more failure. And a great example of that is the cellular industry when they moved from 3G to 4G to 5G. Each technology covered less ground. The problem was when they went from 3G to 4G, they didn't want to put up new towers. And so they literally swapped out the 3G for the 4G equipment and then had coverage gaps in the middle, which meant they had to literally leave the 3G up there as well as a backup to catch those in the gaps until they could address it. And so the same thing applies to Wi-Fi. As you increase from, say, an older 2.4 base design to a 5 design to a 6 design, you're going to see differences in coverage. Yeah, so the newest is always great, but it's not always better. Keep in mind that one-to-one upgrade probably not going to fix your issues. Wi-Fi 7 generally will give you better performance, but with a bad design, the improvements are actually going to end up becoming kind of marginal. If your design was based on something 10 to 15 years ago, it was probably based more on 2.4 or 5. And so 6 and even 5 today are probably going to be too far apart to work correctly. So if you're going to Wi-Fi 7 and you want a 6 gig support, you should be doing a professional design to make sure everything is accounted for. I hear this one occasionally. I have 70 other wireless clients that are fine, so can't be a wireless issue. Clients are each unique. Every device is different, and a wireless VoIP client is especially different. Different requirements are based on different form factor, how they're using it, battery saving goals. Not all devices are equal. You can literally take 2 iPhones or 2 Androids or whatever that are identically configured, set them down side by side, run a speed test, or look at a coverage map, and you're going to see completely different results because there are different tolerances, or actually I should say there's wide range of tolerances on the quality of the chips that are in those devices. Whereas the testing devices that we use from Ekahau or Hamina are designed to be very precise, and they are tested at the factory to make sure they meet that level of precision. Whereas your phone, all they do is they turn it on. Did it work? Okay, it turned on. Great. Put it in the box, ship it to the store. So every device is different. Other factors that can weigh into this: how you carry the device, the build of the person themselves. Are they small, skinny, tall, wide? I'm a beefy guy, and I can tell you without a doubt, I block more RF than some of the people I work with who are skinny and thin. And we've tested that because we've actually tested it in hospitals where they were complaining about issues within the patient rooms, and we discovered it was the patient bodies that were blocking the signals. Other factors such as stickers on the device. People like to put stickers on things, and that's great, but the minute you put that foil backed sticker on your phone, you're blocking your antenna potentially. Is it carried on your hip? Is it in your hand, in your pocket, on the desk, underneath the overhanging metal cabinet? Those are all factors that you have to look at. So don't assume just because everybody else is working that there isn't a wireless issue still at play. This one I always get a chuckle out of. It works fine at home. Keep in mind that home Wi-Fi, the consumer brands, work differently than commercial. Commercial targeted systems are designed for stability and reliability, whereas consumer brands are targeting cheap and widespread coverage. If you ever look at the difference of them, a consumer device has antennas sticking out every which way, which we'll talk about those antennas in a little bit. But a commercial device, you don't see anything. It's a nice shape. It looks like a smoke detector or similar, and it's meant to kind of blend in. So the antennas are positioned differently. They're not designed to cover the entire building with one AP. So consumer grade devices are generally different. There are some that are meant to look nice, like your Orbeez, or some of those are meant to kind of blend in and just look like a little something sitting on a counter or what have you. But some of your main ones, like some of your bigger ones, your Netgears, some of your Asus, and a few others, they've got antennas sticking out every which way. Uh, Keep in mind too that with a commercial design, it's built to have multiple access points. That's how they're designed. And to have a controller in place and try to bring together a system that works everywhere, not just one AP trying to hit everywhere. So you can't apply consumer brand thinking in a commercial space and expect it to actually work. Another one we hear often, and this is often pushed by the vendors, in fact, actually, the vendors are the worst offenders. Wider channels will get us better throughput. On paper, absolutely, this is true. The reality, though, is that a wider channel is going to lead to more interference. It's going to reduce our gain, and more channel reuse is going to occur in large environments. So what works at home with one or two APs is likely not to work in the office with 10 or 12 APs. So I have a whole bunch of charts. I'm not going to go through these in depth. These are in the slide deck for your perusal later. These charts come from the Wireless LAN Professional Group. They're nice graphs of the spectrum charts, and you can actually go to Wireless LAN Professionals and download the PNGs or the PDF files for these if you want. If you're doing any wireless troubleshooting, I highly recommend having these somewhere just to keep the channels straight. So in the 2.4 spectrum, there's only 3 channels that do not overlap, and those are channels 1, 6, and 11. In the US, we don't have access to 12, 13, or 14, which is why I have them blocked off. You can do a 20 or a 40 meg wide channel. Do not ever use 40 megahertz in 2.4. Do not become that neighbor. It clogs the entire spectrum. So if you think about it, this channel, just looking at channel 6, for example, that is 20 megahertz wide. In order to reach 40 megahertz, my channel is going to get wider and start to interfere into channels 1 and channel 11. So basically, a 40 meg wide channel destroys the spectrum, and that will create issues of overlap for other devices. Similarly, in the 5 gigahertz range, we have the option for 20, 40, 80, and 160 megahertz. Some of your biggest offenders to this are your internet providers. So Comcast is a great example, or and it could be any cable provider. I'm not going to beat up on Comcast, but any cable provider will sell you a modem, put it in your house, and they are going to default it to 80 or 160 megahertz. The answer and the reason for that is they want you to have the fastest speed because they want their marketing efforts to show you that they're the better brand than the other guy down the street. The reality is that these wider channels are creating issues, and what a lot of forums will tell you, people in forums, oh, if you're not getting enough speed, make your channels wider. Yes, again, on paper, that is absolutely correct. When you go from a 20 to a 40, you have doubled the throughput. You go from 40 to 80, you doubled it again. So keep that in mind. I mean, you're making a lot more data move, but at what expense? There's a trade-off here. So each channel increase or each width increase is going to reduce your gain by 3 dB. 3 decibels equals 50% of the power. That's huge. So each increase also risks co-channel contention. So keep this in mind. At 20 megahertz, you have 25 unique channels. At 40, you reduce it to 12. At 80, you have 6, and at 160, you have 2. I see 160s being used a lot by people thinking that they're getting better performance out of it, but then they have 8 APs in their building. You are going to absolutely destroy the spectrum, not only for yourself, but for your neighbors as well. 6 gigahertz gets even worse. We have 20, 40, 80, and 160, and now we also have these mega 320s. Let me tell you, at 320 megahertz, you can push quite a bit of data, assuming you can get 320 megahertz of clean spectrum. And it's the same thing all the way down through the other frequencies. It's not as congested today, but give it time. As everybody moves to 6 gigahertz, it also is going to become congested. Everybody seems to think they need the 160s or the 320s. Reality, most of our clients are running at 40 megahertz in the commercial space, and they are doing absolutely fantastic. So when you increase the channel width, each increase drops that by 3 dB. That 3 dB loss of gain also reduces your distance covered. It'll increase your risk of interference because now you're using more channels. Your neighbors might be using them. And then your very wide channels, like 160 on 5 gigahertz, will have to split between DFS and non-DFS channels. And what happens there is if that device picks up traffic from a radar device on that same channel, it will have to vacate the DFS channel, dropping everything to 80 megahertz anyway at that point. So all you're really doing is chewing up spectrum, making it hard for others, and they're going to do things to try to make their network better, which is going to make your network worse. And you're just basically lobbing grenades back and forth at each other over the fence. Nobody wins. Myth number 9, we use auto channel and power. We do not need to fine tune this. Sure, most wireless vendors will claim absolutely fantastic channel and management, power management, but still only use the input from the access points. They're not seeing what your client device sees. And because of that, they're not getting tuned to what your clients need. And keep in mind, if say the access point, you're in a skyscraper, for example, a tall building, downtown Baltimore, and your access points are in the hallway, your offices are along the perimeter facing outward. Your APs maybe don't see the neighbors across the way, but your client device does because you're right next to the window. And when I mean see them, I'm saying electronically, not visually. So you've got a couple of windows and walls between the neighbor and your access point in the hallway, but you're right in the middle. Your access point's not seeing that neighbor's issues and therefore isn't adjusting and accounting for that properly. But your client device is sitting there going, I can't connect to the AP because I've got interference from this other guy right now. And so it can't do anything. And because your device doesn't talk to the access point and tell it, hey, I've got a problem, can you move? You're really not getting the tuning capability that you think you're getting. So not one vendor has gotten this right yet. Some are getting closer, but none have really made it work right yet. It tends to result in poor choices, mostly tends to select non-DFS, chooses the widest channel because its logic says wider is better. It ends up creating a lot of co-channel contention and reuse. I always say manual tuning for the win, assisted by a good validation survey and great wireless modeling using a strong tool like Ekahau or Hamina. There's others out there as well, but they're kind of the two main options on the market. Auto power is also not that much better. Some vendors just power their gear at the highest power available, especially on the consumer grade. The power decisions need to be made using the coverage and overlap information. The controller does not have insight into that. That's coming from the device in your hands, your client device, and they're not getting that information. This is where those tools like Ekahau and Hamina and others can help you get this right. And you can target your designs using the upper middle range of power. This gives you some ability to adjust throughout the day then, or throughout, in the future. You can tune it up a little bit, or you can tune it down a little bit, because things are going to change. People are going to move around in offices, they're going to move furniture, they're going to put up a big screen TV, put up a whiteboard, take down a whiteboard, add a wall, drop a wall. These all are all things that change. And if you can adjust your power up or down, you can accommodate. But if you run everything pedal to the metal all the time, you have nowhere to go but down. You can't increase, and that's going to make it difficult to adjust. Myth number 10. The AP vendor claims it's going to do 4.3 gig. I'm only getting 400. Well, vendors all use the highest theoretical throughput in their advertisements. This is what they've all decided. It's what levels the playing field. So you can look at vendor A, B, and C and see that they all do 4.3 gigs. Now you have nothing to choose from. It is all theoretical. And those throughput levels are based on lab-like conditions and are rated for the highest possible MIMO combination between the AP and the client. Also, the highest channel width. That's not reality. None of this is. So the box said it could do X. Well, like I said, they've all picked that as their standard. In theory, that is absolutely true. And yes, by the way, 4.3 gigs is the theoretical capability of most of your 5 gigahertz devices that support MIMO 4.4. The reality is noise is everywhere. So's your interference, so's your obstruction, and your clients are not typically MIMO 4.4. They're 1.1 or 2.2. Some might be 3.3. Some of your Macs have 3x3 antennas in them. But for the most part, your devices are MIMO 1 or 2 devices. They're advertising the 4.4 rate, which is not going to help you. So here are some real reality checks here. On 5 gig, using Wi-Fi 6 with a MIMO 2.2 client, which is what most of your modern devices are, most of your iPhones, your Droids, your laptops, a 20 meg channel will get you up to 213 megabits. 40 will double that to about 450, and 80 will double that to 960. Do you really need those levels to do your job? If you think about it, a Zoom call takes 10 down, 5 up. Out of 2, you're doing a 20 meg channel, you've got plenty of headroom there. Also, keep in mind, most of your network devices are limited to 1 gig anyway. So pushing multi-gig, if you're not a multi-gig network backbone, it's not going to do much good. So you only need about 10 meg down, 5 to 10 up per Zoom or per Teams call that's going on at a time. So winding down with some honorable mention myths. So these are just some real short ones that I come up with or come across. But, one is hiding the Wi-Fi SSID is going to make things more secure. Anybody with packet sniffing capability can capture that information and find out what your SSID name is. They do not even need to be on your network or physically in the building. If they can pick up the Wi-Fi in your parking lot, they can grab it and do a Wirecap or a Wireshark right there in the parking lot and gather that data. So they'll get the name of your SSID. So hiding it is not secure. Another myth I hear occasionally is that Wi-Fi is not secure, and that's actually not even remotely true. Out of the box, no, it probably is not secure. Out of the box, it's wide open. Here you go, plug it in, have fun. But with solid encryption using WPA3, authenticated logins against a Radius server or something similar, using complex passwords and keeping your firmware up to date, Wi-Fi can be as secure as you need it to be. One of my other favorites is the antenna aiming myth. These pictures are a little hard to see, but this is a classic. We see this where the Omni antennas, if you have external antennas, are pointed towards where they're working. In other words, they think that if I point the antenna towards my desk, I'll get better coverage there. That is not true. The Omni radiates out from the sides of the spike antenna, not out of the tip. The best position for most of these is straight up and down in most cases, not aimed to the side, not aimed at some angles or anything like that. Keep in mind too that an omni pattern is kind of like a donut. And so when you tilt the antennas sideways, you're tilting the donut sideways. So one side of the donut gets great coverage below it, and the other side of the donut is pointing up at the sky. So something to consider. And then also one of the last ones, interference only comes from other Wi-Fi networks. And that is not true. We talked about some of this earlier, but there are lots of other sources out there. Microwave ovens, Bluetooth, wireless video cameras, outdoor links, wireless game controllers, the list goes on and on. We've seen the microwave oven actually recently. Client had a bunch of IoT devices, sensors, temperature sensors, humidity sensors, and other things. They were using them to monitor products that they were making and manufacturing. And every day around lunchtime, the sensors would start going offline. Come to find out that the microwave ovens in the kitchen, or not the kitchen, the break room area, were all up against the wall that on the opposite side were all the sensors. And so when the microwave ovens cranked up, they were blocking the 2.4, creating noise on the 2.4 and blocking those sensors from working properly. So even today, the microwave oven is still a pain in the neck when it comes to, Wi-Fi. Cordless phones really aren't in the 2.4 range anymore, but Bluetooth is. And so we've also seen it in areas that use high numbers of Bluetooth devices. They'll tend to have issues. So to kind of wrap this up, Wi-Fi is often misunderstood by traditional networking resources, and really it's a specialty of its own. If you think about it, many doctors today are very focused on a single, for lack of a better term, ology. You used to have cardiologists. Now you have cardiologists that focus on the electrical and cardiologists that focus on the physical aspects. And the list goes on and on like that. And it's the same thing in networking. A good design, good validation, as well as frequent care and feeding of your network, it's going to give you the best results. You have to stay on it and don't think that it's just going to just keep on chugging along without care and feeding. And honestly, wireless is a critical element of today's business. You really cannot run your business without good wireless. People want to be on the move. They don't want to be tied to their desk. They want to run in and out of conference rooms. You don't want to have network drops everywhere. It also allows you to make an office space that's flexible. You can adjust and accommodate without having to worry about how do we move the wiring. So you want it to work as good as your physical network, and it can. And with that in mind, I'm going to leave you with one last thought. This week, we did a troubleshooting exercise with a client that was having issues that everything said it's a wireless problem. And we followed the standard troubleshooting techniques, the standard best practices. I'm a big believer in a saying, when you hear hoofbeats, think horses, not zebras. So don't think of the exotic, weird things. Think of the common things. And so when there's a wireless issue, or when calls are dropping or things like that, you focus on the wireless issues. And so we beat it up and we followed that all the way. And then we discovered, after we fixed all of the wireless issues, that it was still a problem. Nothing was any really that different. I mean, there were a lot of little wireless issues here and there. So we started diving in a little deeper and started looking for the zebras. And the other night I found two of the zebras, actually. They had an entire section of the building that is poorly wired, as it turns out. And they had two switches going bad, all of which were causing bad packet issues, causing packets to drop. And that was jamming up all of their calls. And so the physical network is just as important as the wireless network. And the problem is not the wireless, it's the physical network itself. So remember, yes, indeed, when you hear hoofbeats, think horses, not zebras. But also remember that sometimes the zookeeper likes to let a few zebras out to make it a little more entertaining and interesting. And so with that, Chris, back to you.
Thank you very much, Alex. So No question here. So obviously you covered a lot of information and covered it well. So thank you very much for that. Just a reminder, you will get the evaluation, and on there's three things that might be helpful to you as you kind of think about whatever your next steps would be that's appropriate for you. So thing that's being offered is a Wi-Fi troubleshooting and tuning meeting together. So kind of learning how can you kind of better improve what you're already doing. Another is you might need a wireless site survey or a design if you're thinking about going over, or a validation engagement to look at what you have, what's there, what issues that you might be having, how to, and what would be kind of the recommendations for improving what you have there, or for a new location. Or you may just want to be able to kind of talk through in a wireless planning workshop, no charge for that, or kind of whiteboarding, where are you now, where do you want to go, what makes sense, talk about the various choices and branches that might make some sense for you. So all those are on the evaluation. You can just select the things that make sense. We'll be happy to follow up and provide you that stuff. So thank you very much to Alex. Thanks to each one of you for spending lunchtime with you. Hope the pizza was good. The information certainly was, and I hope you have a great afternoon. Thank you so much.